Welcome. Today we are looking at multiplication and the distributive property. And the reason I put a picture of engine parts up at the top is because what this means is that we'll be looking at the individual parts of a multiplication problem and how they work. Let's get started. Today we'll answer the question, how can the distributive property show me how the parts of a multiplication problem work? So yesterday we used a standard algorithm to solve problems like this, 24 taken 5 times. And here we can find the product to be, it won't be as nice as it would be if I turned my paper. Be really careful. Okay, 4 ones times 5 ones gives me 20 ones. Can't put that there. There are 0 units in 20 and there are 2 tens. 5 times 2 tens gives me 10 tens, plus 2 more tens gives me 120. So I know that the product of this problem is 120. But what did we actually just do? Well, let's zombify it, ha ha ha. Let's take it apart and take a look at the individual parts. When I set up a problem like this, what I'm really setting myself up to do is to do it one piece at a time, which you already know. We're doing first 4 units times 5 units. So we know that part of this problem is 4 times 5. And we've already established that 4 taken 5 times is 20. Well, the second thing that I'm doing is 5 times 2 tens. So 20 times 5 equals 100. And I know that 100 plus 20 will give me 120. So basically what I've done is taken the pieces and added them, which is all multiplication really is. Okay, so what about 43 taken 6 times? What am I actually doing? Well, what I'm actually doing is 6 times 3, here times here, and then my units times my tens. So I'm really doing 6 times 3 plus 4 tens, which is 40, times 6. Now let's put the parts together. 6 times 3 is 18, plus, well, 6 times 4 is 24. So 6 times 40, we put that 0 on the end, makes it 240. And when I'm all done, I get 18 plus 240, which will give me 258. Now let's check it just to be sure. All right, let's take 43, multiply that by 6. There we are, 258. So what if I want to work with a bigger number, 126 times 3? Well, just like yesterday, we just keep doing the same thing. We know that what this problem really is 3 times 6, and 3 times 20, and 3 times 300. We just got to write that out. So let's do 6 times 3 plus 20 times 3 plus 100 times 3. Is this looking strangely like expanded form to you? Because it is to me. And more or less, it's what I'm doing. So let's work with our totals then. 6 times 3 is 18, plus 20 times 3. 2 times 3 is 6, so 20 times 3 is 60, plus 100 times 3, which is 300. Now, if the numbers are getting big and that bugs you, go ahead and come over here. But lining them up is key. 8 and nothing is 8, 6 plus 1 is 7, 3 and nothing is 3. Let's check it. 126 times 3 equals 378. Looking good. So now let's say you have a try at it. I would like for you to write it out kind of like an expanded form. Let's do one, and then we'll stop, and you can take a look, and I'll show you. All right, so 57 times 4. Go ahead and pause the video and give it a shot. So if you look at it kind of like expanded form, what we're doing really is 4 times 7 and then 4 times 50. So let's do it that way. 7 times 4 plus 50 times 4. Okay, so the next step, go ahead and do. Pause the video. Well, the next step is to get our totals. 7 times 4 is 28. Plus 50 times 4. Well, 5 times 4 is 20. So we know that 50 times 4 is 20 with a 0 in the end, or 200. And then 200 plus 28, and there we go. Get them all together. Now you take a try at 162 times 3. You'll end up with 3 sets of parentheses when you're done. Go ahead and give that a try. So what am I doing? I'm doing 3 times 2, 3 times 60, and 3 times 100. So let's do that. 2 times 3 plus 60 times 3 plus 100 times 3. Got all the parts pulled out. This is properly zombified. 2 times 3 is 6. 6 times 3 is 18, so 60 times 3 will be 180. And then 100 times 3 is 300. Just need to add those up. 300, 180, and 6. 6 and nothing is 6. 8 and nothing is 8. 3 plus 1 is 4. I'm getting a total of 486. Let's check. 162 times 3 gives me, 486. We have got this nailed. We'll work with it some more tomorrow, of course. So what did we answer today? Well, how can the distributive properties show me how the parts of a multiplication problem work? And you've probably noticed that it's a bit like doing multiplication in expanded form. Tomorrow we will work harder with it. Have an awesome, awesome afternoon.